Good day. So for the mathematical induction, a mathematical induction is a method for proving the statements involving natural numbers are true for all natural numbers. And we do have this principle that suppose the following conditions are satisfied with regard to a statement about natural numbers. So the first one is that the statement is true for the natural number 1. This is when we are going to substitute 1 to the variable n in the given mathematical statement. The second one, if the statement is true for some natural number k, it is also true for the next natural number k plus 1. So after we substitute 1 to the value to the variable n, so the next one we are going to substitute k to the variable n and then followed by adding 1. So we do have this example. Use the principle of mathematical induction to show that 1 plus 2 plus k plus n equals 1 half n times n plus 1. So in order to do this, so the first one is verification. So with the given, so simply you're just going to consider the portion with the variable n. Okay? So we do have the n equals 1 half n times n plus 1, in which we are going to substitute 1 to all the variable n. So we do have 1 on the left, since we do have here just the n, then on the right, so we do have here n and n, so you're going to substitute 1. After that, you're going to show that the left is equal to the right. So since we do have 1 on the left, so find a way how can be the right side be equal to 1 also. Remember that in verification, your goal is to show that both sides are the same. So it is not always 1 equals to 1. It may also be 2 equals to 2, 3 equals to 3, 5 equals to 5, as long as you're gonna have the same number for both sides. So next, so on the right side, so we do have 1 over 2 times 1, because we do have here 1 plus 1, so that is equivalent to 2. So as what you can see, we do have 1 equals to 1. Therefore, we are done with the verification. Next. For the induction hypothesis, in which n will be equal to k, so simply you're just going to replace n with k. So in this induction hypothesis, you're going to rewrite the other parts of the mathematical statement given. So as what you can see, the 1 plus 2 plus 3 plus this ellipsis plus were actually copied from the given. Then the rest also, then making n k. So that is the induction hypothesis. Next. The third one is proof. So for the proof, you need the induction hypothesis. If you can remember, we do have the 1 plus 2 plus k, 1 plus 2 plus 3 plus up to k, which is the left side of the induction hypothesis. So you're going to copy it. After you copy the left side, so you'll copy this portion for the proof. So after you copy it, so it is here. Then you'll also gonna copy this, okay? The right side. Actually, what you're seeing is the whole induction hypothesis. And then After that, so as what you can see, this portion is what? So this was copied from the induction hypothesis. Okay? So this is your induction hypothesis. After you copy this, what you need to do is you need to duplicate. So what you need to do is you need to duplicate the portion of the left side of the induction hypothesis in which you do have the variable k. So in duplicating it, so it is here, okay? So by the way, I'll just use the black screen here. So we do have 1. So we have here 1 plus 2 plus 3 plus like that. So k equals to 1/2 k plus 1. So remember, this is the induction hypothesis, this portion. So for the proof in which n will become k plus 1, so what you are going to do, simply you're just going to copy the left side of the induction hypothesis. So we do have 1 plus 2 plus 3 plus k. All right? Then after copying the left side of the induction hypothesis, the next thing that you are going to do, you're going to duplicate the portion with the variable k. So you duplicate it, so that will be plus k. So duplicate. After you duplicate, you are going to add 1. So that would be plus 1. Okay? So where are you going to put the plus 1? You're going to put plus 1 on the k. So if in case your k has, for example, has exponent. So let us just write an example here. Okay. By the way, this example is not really related to this problem. All right. So I'm just giving example. So for example, you do have the plus, for example, you do have k squared over 4. So because you need to duplicate this portion, so you're gonna duplicate this. So in duplicating it, so we're gonna add k squared over 4. So as what you can notice, I put a space in between the k and the squared. All right. For what reason? Because we're going to add 1 because this is the duplicated. So duplicate plus 1. Okay. So we're gonna put plus 1 on the k only, excluding the exponent as well as the other numbers such as the denominator. All right. So that is what you are going to do. So duplicate the term with a k. After you duplicate it, you put plus 1 on k only. So what if, for example, another one? So say we do have 5k say squared minus k over k plus 2. Example only. So again, remember, you need to duplicate. So if you are going to duplicate it, so I'll just use the red one, you need to duplicate this term because it has k. So duplicate. So you're gonna have plus 5. Make the space, make spaces, okay, in between the numbers, the k's, okay? Then we do have k plus 2. So I provided space. Why? Because again, what we need is we need to add 1 on the k only. So in the 5k squared, so we'll put plus 1 on the k only. So excluding the coefficient as well as the exponent. So in this k, the minus k here, so we'll put 1 again. You need to enclose in parentheses. Then on the denominator, the k plus 2, so we'll put plus 1 on the k only. That is, well, so I'm just showing to you examples. All right? So I'll just, well, adjust this addition because of the space. So I'll just move the addition sign here. So not to be covered with a parenthesis. Then extend the bar. Okay, like that. So these are just examples for this portion of duplicating the term with a k. All right? So now I will be removing this because we need to continue the induction of the given problem. So I'll be erasing this. All right. So now we can already continue. Um, okay. So since we already have here the duplicating plus 1, the next thing that you are going to do on the right side, simply you're just gonna copy this. Okay, so copy. So that is 1/2. Also put space. Okay. So that is k plus 1, like that. All right. What you're going to do with this, so you are going to copy, and then what you are going to remember is that you also need to put plus 1 on the k only. So k also excluding the coefficient 1/2 here, as well as with the k plus 1 here, so you'll put plus 1 on the k only. Like that, then enclose in parentheses. All right? Next, you're going to simplify both sides. So in doing that, well, so you just copy this portion, or if you want, you can already watch. You can actually already um all right. So I'll just rewrite it because it's gone. So that is 1 plus 2 plus 3 plus k equals to 1/2. So I'm just rewriting it. Okay, so this is the left side. So I just well, copied it and then duplicating. So duplicating this portion. So we do have the plus k. So duplicate. Um After you duplicate, you put plus 1 on the k. Next, what you're going to do is you're gonna copy this portion. The right side of the induction hypothesis, you're just going to copy it. So provide space in between, like that. Okay. So we copy it. Then after you copy the right side of the induction hypothesis, you're going to put +1 on the K. So we do have two Ks on the right. So you put +1, then open and close like that. Then +1 also, open and close parenthesis. All right. Next. So going back with with simplifying, so we stopped here. So simply what you're going to do, this portion, as what you can see, the 1 plus 2 plus 3 plus k, remember we copied it from the left side of the induction hypothesis. So to make this simple in a way that it will become shorter, so you are going to replace it with the right side of the induction. All right? So you're going to copy the right side of the induction hypothesis, which is 1/2 k times k plus 1, like that. And then you are going to, you're just going to copy the rest, this portion. So you do have the plus k plus 1, like that. On the right side, you can already simplify this. So we do have the 1/2 k plus 1, and then k plus 1 plus 1. So remember, this is just one group. So this is equivalent to k plus 2. The right side is already simplified. So what you need to do is you need to find a way how can the left side be 1/2 times k plus 1 times k plus 2. So in the induction or in the mathematical induction, what you need to remember is you need your knowledge about LCD, factoring, or even multiplying polynomials, um, as well as combining like terms. So you need your knowledge on it. Then you need to apply it in the induction hypothesis. So as what you can see, we do have here 1/2 k times k plus 1, this red one. So this is a fraction. Therefore, what we can apply here is actually LCD. Okay? So we can apply the LCD for this portion because it has fraction. And the LCD for 1/2, and then on the term k plus 1, because this has invisible denominator of 1. So the LCD would be what? It would be 2. For the LCD, usually, if you look at the right side, there's already a clue of what is the LCD. So since the denominator in the right side is 2, so automatic the LCD is 2. That is just a clue. All right? Okay. So let us apply the LCD here. Um, so since we do have the LCD of 2, so we divide it by the denominator of the first term. So which is 2. So 2 divided by 2 is 1. You multiply it to the numerator. So that is 1 times k plus 1. Okay? So simply you're just going to copy it. Next, plus. All right? So since the second term, as what you can notice, this has an invisible denominator of 1 to make it a fraction. So LCD of 2 divided by the invisible 1 here as the denominator of the second term. So we do have 2. So 2 divided by 1 is 2. So you write here 2, multiply it to the numerator. So we do have k plus 1. Like that. All right? Next, you can already apply here factoring. Or if you do not like factoring, you can expand. When I say expand, you can multiply. But in this given, it would be easier to factor because why? As what you can notice, we do have two terms here in the numerator. The k times k plus 1 And then we also have the 2 times k plus 1. Okay, so we do have here two terms. And what is common in the said two terms is having the k plus 1. So you just copy the k plus 1 like that. And then you copy what's remaining. So um after you put outside the k plus 1, so what's left in this term? Of course, it is the k. Copy the operation plus. And then in this term also, you put outside the k plus 1 because you factored it. So what's left is 2. Okay, you close it. And then, because we do have here the denominator of 2, so, well, if you want, so you can put it as over 2, all right? Then you copy the what? The right side. So 1/2 times k plus 1 times k plus 2. So to make it the same, remember this portion, it can be written as also like this way. So if you want, so you can directly, well, put the over 2 as denominator of your coefficient 1/2. So like that. Okay, then it will make your proof showing the left side is equivalent to the right side. All right? And then you're gonna have your conclusion. So what would be the conclusion here? So the conclusion here, so since both steps are valid, okay, valid because we were able to show that in the verification, the two sides are the same, having the same numbers. And then in the proof, we were able to show that the left is equal to the right side. Therefore, the statement is what? The statement is true. You just continue for all positive integers. Again, since both steps are valid, therefore the statement is true for all positive integers. That's it. All right? So, well, that's the first example. Okay. Next. So another one, if we do have, so another example. So 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus like that. And then 1 over n times n plus 1 equals n over n plus 1. All right? So that is the given. Okay. So let us have first the verification. In the verification, so you need to make n 1. So in that case, what we only need is just the portion with the variable. Okay, so just this portion. All right. So we're gonna have what? So we do have 1 over, so 1, I'll just put the 1 here. So 1 times 1 plus 1, like that, equals. Right side, you also gonna make n as 1. like that. Okay, then later you're gonna show that these two sides are the same. So how? So just simplify it. So we do have 1 over 1 times 1 plus 1. So remember the 1 plus 1 here is 2 times 1. So we do have over 2. The same with the right side, that is over 2. So we do have 1 half equals 1 half. Okay, so the two sides are the same. Next, for the induction hypothesis, all right? So for the induction hypothesis, remember, so what we need is we only need to make n as k. So I'll just be erasing this. Okay. So we're gonna have induction hypothesis. So this is induction hypothesis. Okay. So in the induction hypothesis, let us just replace n. So I'll just remove this. So we do have 1 over k times k plus 1, like that. On the right side, we do have k over k plus 1. So that is the induction hypothesis. Next, proof. So in the proof, in which n will be k plus 1. So remember, simply you're just going to copy the left side of your induction hypothesis. So we do have 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4. So you just copy it. Dot, 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 or the ellipsis plus, we do have 1 over k times k plus 1. All right? After you copy it, so what's the next thing that we are going to do? We need to duplicate the portion with a variable k. So duplicating it, we do have 1 uh, over, so k times k plus 1, like that. All right? I think the space won't be enough. So I'll just make it smaller. So duplicate. So we need to duplicate. Provide space. All right. After you duplicate, so what's next? You need to add 1 on k only. So like that. Just on k. So this is k plus 1. Okay. Next, right side, you're going to copy the right side of the induction hypothesis. So you just copy this, copy. So equals k over k plus 1. So provide space also. Because you're also gonna insert the plus 1 on the k only. So plus 1 on the k, plus 1 on the k, open, close, like that. Next, you're going to simplify the left side as well as the right side. So for the left side, what you need to do, so as what you can see, um, the portion here, so the first part of your left side is what? So it is actually equivalent to the, so this portion, this is equivalent to the left side of your induction hypothesis because we copied it from the induction hypothesis. Okay? So to make it shorter, what we can do, we can replace it by the right side of the induction hypothesis. So replace it. So that would become k over k plus 1. All right? And then you're going to copy the rest. So we do have here plus 1 over k plus 1 times k plus 1 plus 1. So that is k plus 2. Then on the right side, we do have k plus 1 over k plus 2. Like that. All right? So left side is already simplified. So, rather, the right side is already simplified. So the left side, as what you can see, this these terms are fractions. So you can apply the LCD. So what would be the LCD of this? So the LCD of this would be what? So the k plus 1 times the k plus 2. That is the LCD, the least common denominator. So LCD k plus 1 times k plus 2 divided by this denominator of the first term, what would be left is just what? The k plus 2. Okay? So that is k plus 2 because we divided. And then you multiply the numerator k. Okay? Copy the operation plus. So k plus 1, this LCD, k plus 1 times k plus 2 divided by the denominator of the second term, k plus 1 times k plus 2. So the answer would be 1. You multiply it to the numerator, it is 1. All right? And then after that, so again, we need to show that it will be k plus 1 over k plus 2. So how? So denominator on the left is the LCD. Then you can actually what? You can actually distribute the k because this is k plus 2 times k. So you distribute the k to the k plus 2. So it will become k squared plus 2k plus 1. All right? After this, so this is the well, the expanded, you need to find a way how can you make it look like k plus 1 over k plus 2. So what you need here is you need the factoring. Okay? You factor the numerator. So in factoring the numerator, so it would become what? So I'll be erasing this portion. So the factors of the numerator is k plus 1 times k plus 1. Okay, copy the denominator k plus 1 times k plus 2. And then copy the right side k plus 1 over k plus 2. So again, this portion are the factors. Okay? So because we are able to factor the numerator, so then as what you can see, we can already cancel. So you can only cancel if you do have factors because the operation is multiplication. Also, we do have division here. So therefore, cancellation is allowed. So after doing that, so you just consider what's left. So we do have k plus 1 over k plus 2 equals to k plus 1 over k plus 2. Therefore, this is equal. So conclusion, since both steps are valid, therefore, the statement is true for all positive integers. Okay? So this is mathematical induction. Thank you.